We're getting good at these algebraic expressions and all the translations we've been doing. This page seems like it's not too much harder than what we've been doing, so I think you can do most of these alone. The first one is, notice the example, 2/3 of a number and 9. When you put two numbers together, when you put two of anything together, it's pretty much adding. So anytime it says a number and something else, or 5 and 7, or 21 and a number, or whatever, it's basically adding. So you are finding 2/3 of this combination. So of means times, and since it's the combination, you do that first so that you have the result of your combination. That's why it's in parentheses. We'll do 3, 4, and 5 together now, and then we'll go back down to the bottom for more. 9 more than the quotient of b and 4. 9 more than the quotient of b and 4. 9 more than, so whatever it is, we're going to do 9 more than it. The quotient of b and 4. The quotient of b and 4. So that means b divided by 4. 9 more than b divided by 4. Number 4. 4/7 of a number minus 6. Of is times. 4/7 of a number minus 6. That's pretty simple. The only thing I wanted to stress was the of part, but we've been doing that enough. You probably don't need me so much anymore to remind you. 3/4 times a number increased by 6. I wanted to do this because these two are the same, 4/7 of a number. This one's 3/4 times a number. They're worded differently, but that's the same thing. Because of means times, it's exactly the same. 3/4 times a number increased by 6. See how that works? Let's shoot down to 9. That's it for the day. 3 times a number in n. Remember, that means pretty much you're adding, you're putting them together. So 3 times that. So I'm going to do them first. Before I can find 3 times it, I need to find out the result. Remember, this does have parentheses. Anytime that you need to do adding or subtracting before multiplication or division, or you need to do the second operation first, that's your clue that you need to have parentheses. That's it for 27 for us. Let's look at 28. 28, we're going to go straight to 6 and 9. That's it for us together on this page. You're getting really good at this. We have substitutions for 3 different variables, a, b, and c. Number 6 has 2 of the variables in it, b divided by a plus 5. I am going to put that in fraction form. I just prefer it that way. So when it says b divided by a, would be 4 divided by 2 times 5. If you don't want to put it in fraction form, you can also choose to do 4 divided by 2 times 5. You could have done it that way too. It's fine either way. You'll get the same answer. It's a matter of preference, but with algebra, you'd spend more time with it in fraction form, and it simplifies a lot of steps, so that's why I like to go ahead and do it this way. Regardless of how you set it up, this way or this way, you go left to right, so you do the division first. 4 divided by 2 is 2 times 5 gives us 10. And down to 9. Whatever we do, We do all of that inside there first. The last thing we'll do is square it because we've got to do inside the parentheses first. So z is 12 minus x is 3 times y, so I need to put in a little times dot. Put that whole thing in parentheses and I square it. I've got two different operations inside the parentheses, so I will do multiplication first because that is the rule of the order of operations. 3 times 2 is 6. So that gives me 12 minus 6 squared. Notice I still have my parentheses because I still have more work to do inside. I still have another operation sign. 12 minus 6 is 6 squared. That gives me 36. That is it for 28 and us. You are on your own for the rest. We'll do a tiny portion from each section on page 29. The first set, you're writing all of the expressions in expanded form. I'm going to look at that. Funny how that R is capital and the rest is lowercase, but whatever. I'll do what it says. The square applies to just the just the R. So you have R times R. Then I have an S, there's no exponent. So it's just one S. You know what, I don't need these dots. I'm gonna rewrite without the dots. T cubed times T times T times T. Now I will write it without the dots, the times dots, because with variables you don't need multiplication symbols of any kind. R, R, S, T, T, T. That's what your answer should look like. Number 5. I'm doing number 5 with you because you've got two parts to it. You've got the part outside the parentheses and then you've got the part inside of the parentheses. The reason we're doing them separately is because this part is squared. This is not squared. So I have just the one V, but I have two of these, R minus 6, R minus 6. Be careful, that square only applies to this right here. This is all by itself and he doesn't get to be squared. So that is what it looks like in expanded form. The next section we do the opposite. We are writing them in exponent form. Number 3, we're doing number 3 just because it's negative and it's a good example of the others. Anyhow, I don't think that you really need any help with this. You can look at the example. It's very similar to number 3. The one thing I just noticed about this font is the exponents are right down even with the variables. I think this would look better written like this, with the exponent up in the air like that. Anyhow, I think that's better, in case that might be confusing. For number 3, we have -9. There is no exponent for -9, so you just have it the one time. You've got R times R, so that would be R squared. You've got S one time, so that's S with no exponent, or you could put a 1 by it, but it's not necessary and it just clutters up your paper. That's why the 1 is understood in algebra. Then you've got T multiplied 3 times, T cubed. Here is number 3 written in exponent form. On to number 4. Notice again, this is just the one time. You've got this same combination of terms 2 times in a row. So when we write it, we'll do 6n, because it's only once. Then we'll do n times p. That part is squared. Number 7 is just like this one. The last thing we'll do is number 3 at the bottom. we are writing these with variable expressions. What is the variable expression that explains the rule of this, that every one of these fit by? Notice that every one has a 9 in the beginning and everyone has the 7 at the end. So whatever my rule is, it will always start with the 9. It will always end with the 7. These remain constant. What changes, what varies, actually I'm going to do the plus, is this number right here that we're multiplying times 9. So this will become my variable. I'm going to choose, as usual, T for Tara. There. That is the variable expression that gives the rule for this. You've got 2 more. So don't forget, 27, 28, and 29.